think the students may enter. Okay, Amrita has entered. Hi Amrita, welcome for the session. We hope very good participation from 9 students. Today we are going to have the classes related to the bridge course, that is related to the 9th standard on physics. If possible, I'll be uploading complete videos related to the physics, if not at least minimum 3 chapters. Okay, so don't miss the class, watch the classes completely. Okay, now you are going to have the videos related to the 9th standard on physics.
Introduction. When we observe the things around us, we feel that they are either at rest or in motion. For example, chairs and tables in a classroom, TV in the home, goalposts on the ground, trees in a garden, electric poles, buildings, etc. appear to be at rest. A flying bird, moving bus, needles of a clock, oscillating pendulum, vibrating tuning fork, air particles in the wind, etc. appear to be in motion. They appear to move because they change their position with time. Distance traveled and displacement. When a body moves, it changes its position continuously. The line joining the successive positions of the body during its motion is called path of the body. In certain time interval, let a body move from its initial position A to a new position called final position B. The length of the actual path of the body is called distance travelled. Distance travelled is a scalar quantity because it has only magnitude but no direction. Bodies can follow different paths to move from initial position A to final position B. Distance travelled may vary from one path to another, but the path of the shortest distance is along the straight line joining A and B. In all these cases, the change in position of the body is in a particular direction from A to B, and it is called displacement S. With respect to reference point O, the initial position of the body is represented by vector OA and the final position by vector OB. Change in position of the body with respect to O is equal to vector OB minus vector OA. Displacement is equal to vector AB. Vector S is equal to vector AB. One can notice that when the body moves from A to B by different paths, actual distance travelled may be different, but the displacement vector AB is the same. Displacement has both direction and magnitude, hence displacement is a vector. Note 1. Distance travelled is a scalar, but displacement is a vector. Second, for a given displacement, there are different paths with different values of distance travelled. Third, shortest path is along the straight line joining the initial and final position. Fourth, magnitude of displacement vector AB is equal to length of the straight line AB. Speed and velocity. On comparing motion of different bodies, usually we make the statement like Car moves faster than the scooter. Cyclist moves slower than the bus. Elephant runs slower than the tiger. Aeroplane moves faster than the fastest train. Boy runs slower than the cyclist. Sachin goes at the highest speed. These are our mental impressions about the state of motion of different bodies. In physics, rate of motion of a body is described by two physical quantities, speed and velocity. Speed. Speed of a body is the distance travelled per unit time without considering the direction. If a body travels a distance s along its actual path in time t, then its speed is given by speed is equal to distance travelled by time taken. V is equal to s by t. Speed is a scalar because the distance travelled is a scalar quantity. We are familiar with the statements like bus is moving with a speed of 60 km per hour. Car moves with 100 km per hour speed. Aeroplane is flying at a speed of 350 km per hour. A cyclist is moving with a speed 36 km per hour or 10 meters per second. Rocket moves with a tremendous speed of more than 10 km per second. The SI unit of speed is meter per second represented by meters per second. Problems. First, a car travels a distance of 150 km in 2 hours of time. What is its speed? Identification of data. Distance travelled S is equal to 150 km. Time taken T is equal to 2 hours. Formula to be used in calculation. Speed is equal to distance travelled by time taken. That equals 150 kilometers divided by 2 hours. That equals 75 kilometers per hour. Second, an ant is moving along a curved path in 5 seconds time. If it travels a distance of 10 cm, what is its speed? Identification of data. Distance travelled S is equal to 10 cm. Time taken T is equal to 5 seconds. Formula to be used. Speed is equal to distance travelled by time taken. That equals 10 cm divided by 5 seconds. That equals 2 cm per second. The speeds of a body may be uniform or non-uniform. Uniform speed. Understand uniform speed. Let us consider a body moving along a path of length 50 meters from A. Observe the position of the body and distance travelled after every interval of 5 seconds. Record the time taken and distance travelled in a table. Note, that is, each interval of 5 seconds, the body travels a distance of 10 meters. Hence, speed of the body in each time interval is 10 meter divided by 5 seconds. That is equal to 2 meter per second. In every interval of time, the speed is same. Distance travelled in each interval of 5 seconds is equal to 10 meters. Speed in each interval of time is equal to 10 meters divided by 5 seconds, that equals 2 meters per second. Uniform speed. To understand uniform speed, let us consider a body moving along a path of length 50 meters from A. Observe the position of the body and distance travelled after every interval of 5 seconds. Record the time taken and distance travelled in a table. Note, distance travelled in each interval of 5 seconds is equal to 10 meters. Speed in each interval of time is equal to 10 meters divided by 5 seconds, that equals 2 meters per second. In every interval of time, the speed is same. Time in seconds, distance traveled in meters. At time 0, body is at A, distance traveled is 0. At time 5 seconds, body is at B, distance traveled is 10 meters. At time 10 seconds, body is at C, distance traveled is 20 meters. At time 15 seconds, body is at D, distance traveled is 30 meters. At time 20 seconds, body is at E, distance traveled is 40 meters. At time 25 seconds, body is at F, distance traveled is 50 meters. Such a speed is called uniform speed. It is defined as the speed of a body is uniform if it travels equal distance in equal intervals of time. Distance time graph. Motion of a body can be represented by a line graph. Observations of distance traveled at different times are plotted on an XY graph. Time is plotted along x-axis and distance traveled along y-axis. Consider the first observation in the table. Time is 0 and distance traveled is also 0. Mark the point at the origin 0, 0. For second observation, time is 5 seconds and distance traveled is 10 meters. Mark the point 5, 10. Go on marking points for every observation. Look at the distribution of points. They fall on a straight line. Join the successive points by a segment of line. All points lie on a straight line. Such a straight line or linear graph is obtained for the motion of a body with uniform speed. In other words, if the distance time graph of a body in motion is a straight line, then it is moving with a uniform speed. Time in seconds, distance traveled in meters. At time 0, body is at A, distance traveled is 0. At time 5 seconds, body is at B, distance traveled is 10 meters. At time 10 seconds, body is at C, distance traveled is 20 meters. At time 15 seconds, body is at D, distance traveled is 30 meters. At time 20 seconds, body is at E, distance traveled is 40 meters. At time 25 seconds, body is at F, distance traveled is 50 meters. Such a speed is called uniform speed. It is defined as the speed of a body is uniform if it travels equal distance in equal intervals of time. Motion of a body can be represented by a line graph. Observations of distance traveled at different times are plotted on an XY graph. Time is plotted along x-axis and distance traveled along y-axis. Consider the first observation in the table. Time is 0 and distance traveled is also 0. Mark the point at the origin 0, 0. For second observation, time is 5 seconds and distance traveled is 10 meters. Mark the point 5, 10. Go on marking points for every observation. Look at the distribution of points. They fall on a straight line. Join the successive points by a segment of line. All points lie on a straight line. Such a straight line or linear graph is obtained for the motion of a body with uniform speed. In other words, if the distance time graph of a body in motion is a straight line, then it is moving with a uniform speed. We can make use of the distance time graph for obtaining different information of a body in motion. Let us study this little later. To understand non-uniform speed, let us consider a body moving along a curved path of length 50 meters from A. Observe the position of the body and distance travelled after every interval of 5 seconds. Record the time taken and distance travelled in a table. Time in seconds, point reached, distance travelled in meters. At time 0 seconds, point reached is A, distance traveled is 0 meters. Time 5 seconds, point reached B, distance traveled 5 meters. At time 10 seconds, point reached is C and distance traveled is 20 meters. At time 15 seconds, point reached is D, distance traveled is 30 meters. At time 20 seconds, point reached is E, distance traveled is 40 meters. At time 25 seconds, point reached is F, distance traveled is 50 meters. To understand non-uniform speed, let us consider a body moving along a curved path of length 50 meters from A. Observe the position of the body and distance travelled after every interval of 5 seconds. Record the time taken and distance travelled in a table. Time in seconds, point reached, distance travelled in meters. At time 0 seconds, point reached is A, distance travelled is 0 meters. Time 5 seconds, point reached B, distance travelled 5 meters. At time 10 seconds, point reached is C and distance travelled is 20 meters. At time 15 seconds, point reached is D, distance travelled is 30 meters. At time 20 seconds, point reached is E, distance travelled is 35 meters. At time 25 seconds, point reached is F, distance travelled is 50 meters. The distance travelled by the body in successive intervals of 5 seconds and the corresponding speed of the body are as follows. Time interval is equal to 5 seconds. Time first 5 seconds, distance travelled in each interval 5 minus 0 is equal to 5 meters. At time second 5 seconds, distance travelled in each interval 20 minus 5 that equals 15 meters. For time third 5 seconds, 30 minus 20 is equal to 10 meters. For time fourth 5 seconds, 35 minus 30 is equal to 5 meters. For time fifth 5 seconds, distance travelled 50 minus 35 is equal to 15 meters. See that distance travelled in various equal intervals of time are not same. As a result, speed of the body varies from one interval to the other. For the first time interval, it is 1 meter per second. Similarly, for successive time intervals, it is 3 meters per second, 2 meters per second, 1 meter per second and 3 meters per second. Note that speed is not constant. It varies with the interval when the body is said to be moving with non-uniform speed. The distance time graph for this body moving with non-uniform speed may be plotted as in the previous example. Look at the distribution of points in the graph. Will they fall on a straight line? No. Join the successive points. The graph shows zigzag line or the graph is not a straight line. A zigzag distance time graph line is obtained for a body moving with non-uniform speed. In other words, a zigzag distance time graph shows that body moves with a non-uniform speed. Usually, the motion of the bodies we observe around us are of this type. In such cases, we calculate average speed of the body. It is given by average speed is equal to total distance travelled divided by total time taken. In the present example, total distance travelled is 15 meters and total time taken is 25 seconds. Then the average speed is equal to 50 meters divided by 25 seconds, that equals 2 meters per second. In general, if a body travels distance s1 in time t1, s2 in time t2, s3 in time t3, then the average speed is given by average speed is equal to s1 plus S2 plus S3 whole divided by T1 plus T2 plus T3. That equals total distance travelled divided by total time taken. Distance travelled by a body in successive intervals of 5 seconds and the corresponding speed of the body are as follows. Time, first 5 seconds, distance travelled in each interval, 5 minus 0 is equal to 5 meters. Speed is equal to distance travelled by time taken, that is 5 meters divided by 5 seconds, that equals 1 meters per second. At time, second 5 seconds, distance travelled in each interval, 20 minus 5, that equals 15 meters. Speed, 15 meters divided by 5 seconds, that equals 3 meters per second. For time, third 5 seconds, 30 minus 20 is equal to 10 meters. Speed, 10 meters divided by 5 seconds is equal to 2 meters per second. For time, fourth 5 seconds, 35 minus 30 is equal to 5 meters. Speed, 5 meters divided by 5 seconds is equal to 1 meters per second. For time, fifth 5 seconds, distance travelled 50 minus 35 is equal to 15 meters. Speed, 15 meters divided by 5 seconds is equal to 3 meters per second. See that distance travelled in various equal intervals of time are not same. As a result, speed of the body varies from one interval to the other. For the first time interval, it is 1 meter per second. Similarly, for successive time intervals, it is 3 meters per second, 2 meters per second, 1 meter per second, and 3 meters per second. Note that speed is not constant. It varies with the interval when the body is said to be moving with non-uniform speed. It is defined as follows. Velocity. The rate of change of displacement is called velocity. Velocity is equal to displacement divided by time. V is equal to S by T. We know that displacement is a vector and time is a scalar. Hence, velocity is a vector. Units of velocity and speed are same. Normally, they are expressed in the form of kilometer per hour or meter per second or centimeter per second, etc. SI unit of velocity is meter per second. Uniform velocity. Consider a body moving from A to X along the straight path. It covers 100 meters in 50 seconds. Time 0 seconds. Displacement 0 meter. Point reached A. Time 10 seconds. Displacement 20 meters. Point reached B. Time 20 seconds. Displacement 40 meters. Point reached C. Time 30 seconds. Displacement 60 meter. Point reached D. Time 40 seconds. Displacement 80 meter. Point reached E. Time 50 seconds. Displacement 100 meter. Point reached F. In X by 10 seconds, it is traveling 20 meters and reaches the points B, C, D, E and F successively such that AB is equal to BC is equal to CD is equal to DE is equal to EF, that equals 20 meter, and time interval is equal to 10 seconds. In other words, in successive time intervals of 10 seconds, the displacements AB, BC, CD, DE and EF are all equal in magnitude and direction. Hence, the velocity of the body in all equal intervals of time must be equal, and it is given by velocity is equal to displacement by time. That equals 20 meters divided by 10 seconds. That equals 2 meters per second. If magnitude and direction of velocity of a body for all intervals of time are same, then its velocity is called uniform velocity.
Speed and velocity. The velocity of a body may be uniform or non-uniform. Uniform velocity. Velocity of a body is said to be uniform if it undergoes equal displacement in equal intervals of time, however small the time interval may be. Non-uniform velocity. Velocity of a body is said to be non-uniform if it undergoes unequal displacement in equal intervals of time, whatever the time interval may be.
Non-uniform velocity. Consider a body moving from A to C along a straight path. It covers 100 meters in 20 seconds. In first 10 seconds, it travels a distance of 60 meters and reaches B in next 10 seconds. It travels 40 meters and reaches C. Velocity of the body during displacement AB is equal to AB divided by time. That equals 60 meters divided by 10 seconds. That equals 6 meters per second. Velocity of the body during displacement BC is equal to BC divided by time. That equals 40 meters divided by 10 seconds. That equals 4 meters per second. Note that the velocity of the body in specific intervals of time of 10 seconds are not equal. Then the velocity of the body is said to be non-uniform. Motion of a body can be represented by a line graph. Observations of distance travelled at different times are plotted on an XY graph. Time is plotted along x-axis and distance travelled along y-axis. If the distance, time graph of a body in motion is a straight line, then it is moving with a uniform speed. A zigzag distance time graph shows that body moves with a non-uniform speed. Example 1. Find the following from the graph. Is the speed of the body uniform or non-uniform? Solution. The graph is a straight line, hence body moves with a uniform speed. What is the distance travelled by the body in 15 seconds? Distance travelled by the body in 15 seconds is 3 meters. How much distance body travels in time between 10 seconds and 20 seconds? Distance travelled in 10 seconds is equal to 2 meters. Distance travelled in 20 seconds is equal to 4 meters. Therefore, distance travelled between 10 seconds and 20 seconds is equal to 4 meter minus 2 meter, that equals 2 meter. How much time is required to cover 6 meter? To travel 6 meter, body requires 30 seconds. What is the average speed in 25 seconds? From the graph, body travels a total distance of 5 meter in 25 seconds. Therefore, average speed is equal to distance travelled divided by time. That equals 5 divided by 25. Therefore, average speed is 0.2 meters per second. Use of distance time graph. Using distance time graph of a moving body, we can obtain the following information. First, nature of the speed is uniform or non-uniform. Second, distance travelled from starting point in certain time. Third, time required to travel a certain distance. Fourth, distance travelled in any interval of time. Fifth, speed of the body in certain intervals of time. of velocity of the body. Solution. Looking at the zigzag nature of the displacement time graph, one can say that body moves with non-uniform velocity. Second, what is the displacement of the body in 20 seconds? Body undergoes displacement of 18 meters in 20 seconds. Third, what is the velocity of the body in second 10 seconds period? Displacement of the body in 10 seconds is equal to 3 meters. Displacement of the body in 20 seconds is equal to 18 meters. Displacement in second 10 seconds is equal to 18 minus 3, that equals 15 meter. Therefore, velocity is equal to 15 meter divided by 10 seconds. That equals 1.5 meters per second. Fourth, what is average velocity of the body in 30 seconds? Time is equal to 30 seconds and displacement is equal to 21 meter. Hence, average velocity is equal to 21 meter divided by 30 seconds. That equals 7 divided by 10. That equals 0.7 meters per second. Acceleration. Consider a cyclist moving on a straight road. Before he starts pedaling, his velocity is 0. As he pedals, his velocity increases with time. After certain time, he moves with a constant velocity. If the road is clear and good, to stop the vehicle at his destiny, cyclist stops pedaling and applies brake. Gradually, his velocity decreases and comes to rest. Notice that velocity increases in the beginning, whereas it decreases while stopping the bicycle. Hence, there is a change in magnitude of velocity but not in direction. Acceleration. Consider a cyclist moving on a straight road. Before he starts pedaling, his velocity is 0. As he pedals, his velocity increases with time. After certain time, he moves with a constant velocity if the road is clear and good. To stop the vehicle at his destiny, cyclist stops pedaling and applies brake. Gradually, his velocity decreases and comes to rest. Notice that velocity increases in the beginning, whereas it decreases while stopping the bicycle. Hence, there is a change in magnitude of velocity but not in direction. Consider a body moving in a circle with constant speed. Though the speed of the body is constant, observe that magnitude of velocity remains constant but its direction is continuously changing. There is a change in direction of velocity but not in magnitude. The change in velocity means the change in magnitude or direction or both. In the above two cases, there is a change in velocity, then the body is said to be accelerated or body is moving with an acceleration. For a body moving along a straight line, the acceleration of the body is defined as follows. Acceleration equals change in velocity divided by time. Consider a body moving in a circle with constant speed. Though the speed of the body is constant, observe that magnitude of velocity remains constant but its direction is continuously changing. There is a change in direction of velocity but not in magnitude. The change in velocity means the change in magnitude or direction or both. Let u be the initial velocity of a body. After time t, its velocity be v. Then its acceleration is given by acceleration is equal to final velocity minus initial velocity whole divided by time. Vector A is equal to vector v minus vector u whole divided by t. SI unit of acceleration. Unit of acceleration is equal to unit of velocity divided by unit of time. That equals meters per second divided by second. That is equal to meters per second squared. The SI unit of acceleration is meter per second squared. Different cases. Case 1. If the body moves with a uniform velocity, then there is no change in velocity with time. Vector v is equal to vector u. Therefore, change in velocity v minus u is 0. Acceleration is equal to vector a, that equals vector v minus vector u whole divided by t. That equals vector o divided by t. That equals vector o. Acceleration is 0 if velocity is constant, or for a body moving with uniform velocity, the acceleration is 0. Time in seconds, velocity in meters per second. At time 0, velocity is 10 meters per second. At time 1 second, velocity is 10 meters per second. At time 2 seconds, velocity is 10 meters per second. At time 3 seconds, velocity is 10 meters per second. At time 4 seconds, velocity is 10 meters per second. Let u be the initial velocity. Consider a body moving in a circle with constant speed. Case 2. If the velocity of the body increases with time, the change in velocity v2 minus v1 is positive. Hence, acceleration is positive. Acceleration of a body is positive if its velocity increases with time. Time in seconds, velocity in meters per second. At time 0 second, velocity is 10 meters per second. At time 1 second, velocity is 5 meters per second. At time 2 seconds, velocity is 10 meters per second. At time 3 seconds, velocity is 15 meters per second. Case 3. If the velocity of the body decreases with time, then change in velocity v2 minus v1 is negative. Hence, the acceleration is negative. Acceleration of a body is negative if its velocity decreases with time. The negative acceleration is called retardation. Time in seconds, velocity in meters per second. At time 0 second, velocity is 20 meters per second. At time 1 second, velocity is 18 meters per second. At time 2 seconds, velocity is 16 meters per second. At time 3 seconds, velocity is 14 meters per second. At time 4 seconds, velocity is 12 meters per second. At time 5 seconds, velocity is 10 meters per second. Example 1. If acceleration is equal to minus 4 meters per second squared, then retardation is equal to 4 meters per second squared. Example 2. If retardation is equal to 2 meters per second squared, then acceleration is equal to minus 2 meters per second squared.
Circular motion. At any moment, force acts at an angle to the direction of the motion. The body moves along curved path by changing its direction. Body is said to be in uniform circular motion when body with constant speed moves in circular path. Example, train taking curved path, athletes running in circular path, merry-go-round or giant wheel. When stone is tied to string and revolves around one's head, it is circular. Revolving of moon around the earth and earth around the sun, respectively, are almost in circular orbits.
Illustration of centripetal force. Earth moves in a nearly circular path around the Sun. The gravitational pull exerted by the Sun on Earth provides the necessary centripetal force.
Centripetal force. Radial force directed towards the center acting on a body in uniform circular motion is called centripetal force. This motion is always radial because centripetal force changes continuously. Force F equals mv squared by r. Mass m. V constant speed. R circular path radius. Let's consider a stone tied to a string and held whirling around. Centripetal force is provided by tension in the string. Stone is at position A, but it is pulled continuously towards the center. At this instant, the stone is moving in the direction of the tangent AA, which is perpendicular to OA. The velocity is in the direction BB, which is perpendicular to OB. Stone is at position B. Newton's law of motion, stone is said to be in the motion with velocity v unless acted upon by an external force. Vehicle may skid because the centripetal force is supplied between the wheels and the road. Prevent skidding and damages to the tires, road bend has to be inclined suitably by raising the outer edge over the inner. Prevent train from going out of track and to reduce wear and tear of the wheels, outer rail is raised a little above the other. Obtain centripetal force, run on leans inwards. If the road bend is tilted properly, the inclination provides centripetal force. Centrifugal reaction. Centrifugal reaction is defined as the reaction force exerted by the body on the external agency, which provides centripetal force. This reaction is equal and opposite of the centripetal force. Stone exerts an outward force, namely centrifugal reaction, on the hand when stone whirled round by a string in hand. Centrifugal force has no real existence. Centrifugal force is due to inertia of rotational motion. Centrifugal force cannot be created. It is experienced only in the context of circular motion. Astration. Shallow dish containing mercury and water is rotated a vertical axis. Water will be at the center with mercury around. Centrifugal force is larger on mercury molecules than on water molecules because mercury molecules are heavier.
Consider a passenger sitting in a bus. Moving along a straight road, passenger tends to fall back when the bus is suddenly accelerated, and he tends to fall front when the bus is suddenly retarded by applying brake. This is due to inertia of the body to remain in the same state of motion. In both the cases, there is no real force pushing him back or forward. With respect to the bus, upper portion of the body appears to experience a force. Hence, this inertial force is a pseudo force, but it is equal and opposite to the force exerted on the vehicle by the road.
Different densities of minute particles are separated by centrifuge. A small tube containing particles in a liquid are suspended in a circular frame and rotated at high speed in a horizontal circle. Because of the centrifugal force, lighter particles move towards the axis and heavier particles move away from the axis. The particles of different densities are separated. Separating proteins, hormones, and viruses, centrifuge is very useful. Centrifugal drying machine. If clothes are placed in the cylinder which is perforated and rotated on its axis, set into rapid rotation. Due to centrifugal force, water is forced and clothes are dried.
Okay, this completes the first chapter under physics, the motion. And we'll move on to the next chapter. Okay, the next chapter will be force and laws of motion. Please try to note down the important points.
Chapter 9, Force and Laws of Motion.
Before we study Newton's law, we need to know to change the velocity of a body an external force is needed. Hence, Newton's law states that every body continues in its state of rest or uniform motion in a straight line, unless it is compelled to change that state by forces impressed on it. Significance of the first law. 1. Tendency of the body to continue in its state of rest or of uniform motion until and unless an external force acts upon it. It is called the inertia. 2. Until and unless compelled by a force means resultant of existing forces will be zero. 3. There is no need to apply force for a body to enable it to continue in its state of uniform motion. Property of the inertia of bodies can be shown by the following example. Close the mouth of the bottle by placing the glass plate. Coin is placed on the glass plate just above the open of the mouth of the bottle. Now, suddenly pull away the glass plate. The coin is found to fall into the bottle. So, this explains that when force acts on the plate, coin suddenly falls into the bottle. Newton's second law of motion. This law states that the acceleration given to a body by force applied to it is directly proportional to the force and is in the same direction as the force and inversely proportional to the mass of the body. Newton's second law of motion. This law states that the acceleration given to a body by force applied to it is directly proportional to the force and is in the same direction as the force and inversely proportional to the mass of the body. This law relates force, mass, and acceleration. Let m be the mass, resultant force acting on the body be F, and a be the acceleration. According to the law, acceleration is directly proportional to force. Acceleration is inversely proportional to mass. By defining unit force, where k is equal to 1, the SI unit of force is Newton. 1 Newton is that amount of force which acts on a body of mass 1 kg, produces an acceleration of 1 meter square, 1 meter second square. Momentum. Momentum of the body is the quantity of motion possessed by the body and is equal to the product of its mass and velocity. Initial momentum of the body, final momentum of the body. Change in momentum after t seconds. Rate of change of momentum, where A is equal to V minus U upon t. From this, we can state that Newton's second law of motion as the rate of change of momentum is directly proportional
to the impressed force and takes place in the direction of the application of the force. Newton's third law. It states that for every action there is an equal and opposite reaction. Two forces which participate in the mutual actions of any two bodies is termed as action and the other one is the reaction. Two springs A and B are suspended from the hook. Both the springs have the same reading. Lower spring B pulls upper spring A downwards. Upper spring A pulls the lower spring B upwards. P is the point where the spring remains steady. The two forces Fa and Fb must be equal in magnitude but opposite in direction, both balancing each other at P. Now, we explain about the gravitation of Earth. Objects thrown vertically upwards move for a certain distance and then fall back to the ground. It is due to the gravitational force of the Earth. Acceleration gained by the bodies due to the gravitational force is known as acceleration due to gravity. For vertically downward motion, for vertically upward motion, equations of the motion are given by Newton's law of gravitation. The law states that gravitational force is directly proportional to the mass of the Earth and the mass of the falling body and inversely proportional to the square of the distance. Work is said to be done when force is applied to the body to displace it in the direction of the force. SI unit of work is joule. Example, if a person lifts stone from the ground, some work is done because it has been actually displaced from the ground. Thus, work is said to be done if the point of application of force moves.
Okay. This completes the physics 2 lessons and we'll move on to the next chapter tomorrow. Tomorrow we'll be continuing with the physics bridge course with the rest of the lessons. Thank you for your visit and watching. Thank you one and all. Be serious about the classes and regularly attend the live sessions and note down the very important points. Thank you one and all.